I'm subtracting for the exponent. And by the way, one more thing. For the exponent right here, is any kind of number works. No need to be the whole numbers, okay? You can have decimal, fraction, could be anything for the exponent, okay? You can apply the formulas for any kind of, any type of number for the exponent, okay? Another one, about a to the n, everything to the m is a to the n times m, okay? How about a to the negative n, and you don't want to see the negative sign in front of the exponent, flip it over, reciprocal a, so 1 over a to the n. How about this? A times b, everything to the n is a to the n times b to the n. Okay. How about multiplying and how about dividing? A over b to the n will be a to the n over b to the n. Okay. Is there any more? How about this? I'll make another asterisk then. If you have a to the n equal to a to the m, then you can say that n is equal to m. You have an equation, exponential equation. Base on the left equal to base on the right, then the exponent on the left will be equal to exponent on the right. Okay? Alright, now let's move on to the second type formula. I'm going to talk about the logarithmic formula. Let me go to this side then. Log formulas. Keep in mind that we are reviewing, okay? It means that I believe you guys seen it already, at least in college algebra. So we're gonna bring it back, not like the first time seeing it. Should be brand new. Let's start with the log one. I have log base a of 1. And keep in mind that I used a as a base, so a going to satisfy the condition positive and different from 1, okay? What is that equal to? You ask yourself, a is a base, right? Raised to what exponent? Give me back number 1. Answer is 0. A to the 0 exponent, give me back number 1. It comes from here. A to the 0 equal to 1. Second one, log base a of a equal to 1. A raised to what exponent? Give me a. Answer is 1. A to the first power equal to a. A to the first power equal to a. A little bit more general. Log base a of a to the n is equal to n, because a to the n is a. Write a little bit down here. A to the n is equal to a to the n. Okay? With this type of formula, I used to encourage students to think of it this way. Whenever you have an exponential inside the log, just a single exponent like this. What I encourage students to think of this way. You're going to bring the exponent and put it in front. Outside the log, put it in front. Look. Log base a of a to the n. Bring it outside, it becomes n times log base a of a. And you know log base a of a is 1, so this is n times 1, which is n. Okay? It has meaning behind it, but this is how we should think of it. It's make it quick for you guys to practice. Okay? More general. Log base a of, say, m to the r. M could be any number, and r is exponent. And bring the exponent now. So r times log base a of m. Okay. Now here come one of the main log equation or log formulas that I want you to have it with you for a while. Log base a of a product, say n times m. Okay? You got product 2 factors inside the log. And if you want to break it down, it becomes log base a of n plus log base a of m. Okay, so product becomes the sum. Where does that form? This where does this formula come from? That's really the inverse of the one right here that you see. See, what we say is right here. You want to look for the exponent of the product of two numbers, and what is it? And what is it about? It is equal to the exponent of the first number plus the exponent of the second number. So the exponent of the product equal to the sum of two exponents. Let's say, see, you have a product, right? And you look at the exponent of this product. Take a to the n times a to the n. What is the exponent of this product? It is n plus n. Okay? Exponent of the product equal to the sum of the exponent of two factors. And similarly, what if you have a quotient, log base a of n over m? Guess what? That's addition that becomes subtraction. Log base a of n minus log base a of m. Okay, and of course, you see it comes from here. The exponent of that fraction is equal to the exponent of the top, which is n, minus the exponent of the bottom, which is m. Okay? Let me combine the two formulas right here and help you to get to the more general formula as one. So just keep it in your pocket whenever you see from exponential or log problems, you know what to do. Okay, if you have a more general formula, log base a of say m times n over p times q. So there are several factors in this log. We've got two factors on the numerator and another two factors on the denominator. And what if we want to break that big fraction out? And we're going to be equal to log base a of m plus log base a of n minus log base a of p minus log base a of q. The rule is this: any factor on the numerator will go with a plus sign. Any factor on the denominator will go with a minus sign. Okay, so log m on top is positive, log n on top positive, p denominator negative, and q denominator is negative as well. Okay, and this is a very common question that I've seen over and over. And see what this is product. How come it's a minus? And the answer is this: you have on top, no question, right? Subtract, supposed to be like this. Okay, now it's plus. But you have to subtract the whole sum. So instead of write the whole sum in parentheses and put a minus outside, we can distribute that negative sign into the two terms. So we can get rid of that parenthesis, get rid of that parenthesis, and the plus sign now becomes the minus sign. All right? And this is the formula that I claim that's like the most useful one, in my opinion, when you deal with the log. I've seen this all over. Okay. Oh. Let me talk about a very, very common, typical mistake, I would say, that I've seen over and over when you guys, students in general, right, do math with log. We have this, say, log base a of m plus n. And I was quite a number of students will write this way: log base a of m plus log base a of n. And I claim this is incorrect. You can only have the sum of two logs only if this one is a multiplication, okay? Multiplication. And then you can break it out. Factor right here becomes a sum. You have the sum right here. Can't simplify it that way. So it's wrong. It's not right. Okay? Be careful with this. And similar to the exponential formulas, if you have, make another asterisk. If you have log base a of m, n, equal to log base a of m, then you are safe to say that n is equal to m. Okay? Two numbers equal to each other, they have the same base, and for sure the exponent on the left-hand side be equal to exponent on the right-hand side, and vice versa. All right. That's pretty much good from call this algebra, I think. And now, if you guys take the trick already, let me extend the video clip a little more and recall some inverse trig function for those who take trigonometry already. If you haven't taken trigonometry yet, then that's okay. It's just another chance to see a new thing for you guys, and don't worry about this. Okay? So we have trig function. Trig functions. Let me just recall it. The three basic trig functions that you guys are gonna learn when you get to calculus or in the trigonometry class. It's gonna be sine, cosine, and tangent, and that's good enough. The other three, cotangent and secant and cosecant, pretty much do the same way. First of all, in order to have the trig function, first of all, trig function is not a one-to-one function. Say, for example, the sine function, sine of x, y equal to sine x. The graph going to look like this. Okay? It's not one-to-one function. 0 right here. Sine of pi over 2 is equal to 1. And this is negative pi over 2. And keep going up and down. It's a wave function. And of course, if the function is not one-to-one, you're not going to have an inverse function. So, in order to have the inverse function, somehow we have to restrict the domains of that, the function to be one-to-one. So we're not going to talk about sine function exponent from negative infinity to positive infinity anymore. We're going to truncate it. We're going to narrow it down from just pi over 2 to pi over 2. Okay? So, negative pi over 2 less than or equal to x, less than or equal to pi over 2. Now, this function, from the point right here all the way to the point right here, it passes the horizontal line test, so it's going to be a one-to-one function. And now it's one-to-one function, you can find the inverse. Inverse of this is going to be x equal to sine y. Sine y. We don't write this way, we write this. Either y equal to, I like this way. Or so I write first arc sine of x, or you can write y equal to sine inverse of x. Okay? Either way means the inverse. This is the inverse. Inverse. Okay? For the original function x going from negative pi over 2 to pi over 2, then for the inverse, y will be from negative pi over 2 to pi over 2. Change y to x. Okay. Similarly, for cosine function, if you have y equal to cosine of x, let me draw the graph for you. The graph going to be like this. Okay. Kind of like this. Keep going up, going down. 0 right here. This is pi over 2. This is pi, and again, you see that this is negative 1. This is 1. This graph obviously is not one-to-one. Same idea as before. We want to restrict the domains so that we have a one-to-one function. We're going to restrict x from 0 to pi. Okay, so 0 less than or equal to x, less than or equal to pi, now that the function is one-to-one. So we can have the inverse. Inverse is going to be x equal to cosine of y, and of course we don't write this way, we write what? Y equal to arc cosine of x, or y equal to cosine inverse of x. Either way of writing would be good. And condition for y is 0 less than or equal to y less than or equal to pi. Change y to x, x to y. Okay? And then the last trig function that I want to show you in here is, I don't think again, how about this? Y equal to tangent x. The graph of tangent is going to be like this. Let me use red color to draw it like that. Looks like this. Okay? Alright? course, not one-to-one. And we're going to, same strategy as before, we're going to restrict the domain, make it one-to-one. And we don't study all over the domain of graph. We only restrict down to the period of it from negative pi over 2 to pi over 2. Okay, so we have negative pi over 2. Strictly less than x, strictly less than pi over 2. You see why we don't take pi over 2 or negative pi over 2 this time? Because it's the vertical asymptote right there. You don't have the value for function at that point. Not like the sine function. Inverse is going to be x equal to tangent of y. Same way of writing, we can write y equal to arctangent of x, or write y equal to tangent inverse of x. Both same way, where negative pi over 2 less than y less than pi over 2. Okay, and pretty much that is the end of our review of the exponential and the log function. In the last part, I'll just extend the concept a little bit more. I'll talk about inverse of the trig function. Hopefully this video clip is helpful to you guys. If you have any question, please email us. Thank you very much.